All right, 5.4, systems of nonlinear equations. So you guys have learned how to solve systems of equations by elimination, substitution, and graphing. But now we're going to do that when they are not linear. So some of them could be linear mixed in, but we're going to have quadratics and circles and all kinds of fun stuff. So we're going to solve nonlinear systems of equations by substitution, sorry about that, and graphing. Now, elimination is possible, but it's usually a little bit harder. They all have to match up. So this first one says, use substitution to find all solutions of this system of equations, then show the solutions graphically. So we need to pick one of these equations and solve for one variable. Well, I don't want to solve for either of these top ones, the x squared or y squared, because when I square root, I'm going to get plus or minus. And that just makes it really difficult right now to start with. So I'm going to come down here and I'm going to solve for x. So I got x to be negative y. So now I'm going to go plug that into the other equation. So remember, a negative squared is just a positive. Divide by my 2. So I got y to be plus or minus 2. So I have to do a couple of things here. I have to put in when y is positive 2, then x is negative 2. And when y is negative 2, x is negative negative 2, which would be 2. So I found two solutions, negative 2, 2, and 2, negative 2. So let's show that graphically. So we already solved, let's see, no, we solved for x. So let's go ahead and solve for y, and x plus y equals 0. Well, y would be negative x. So I have a y-intercept of 0 and a slope of negative 1. So this other one, the x squared plus y squared equals 8, this is set up for circle, the circle formula. Remember, it's x squared plus y squared equals r squared. So here my r, or the radius, is radical 8, which is 2 radical 2, which is approximately 2.8. So I know I'm going to go out about 2.8 and have that radius all throughout. And bear with me on my circle, but here we can see I have a solution of negative 2, 2, and positive 2, negative 2, which is what we saw. All right, let's do this one. Use the elimination method to find all solutions of this system of equations. So I'm going to look here and see, well, what could I eliminate? I can't eliminate the y's because this is just a y and this is a y squared. So there's nothing I could eliminate those with. But however, I have an x squared and an x squared, so I'm going to eliminate the x squareds. And I can still eliminate. All right, eliminate. There, that looks better. So let's see, I'm going to multiply the second equation by -2. And I'm going to add it to the first equation. So I got 2y squared plus 4y equals 6. So let's set that equal to 0, since it's a quadratic. I can divide by 2 all the way through. And let's see, can I use my AC method on this one? I can. So I got y to be -3 and +1. All right. So let's see. When y is -3, let's go solve for x. So we can put it in the top or the bottom one. It doesn't really matter. I'm going to go ahead and put it in the top equation. All right, so I got plus or minus 5 over radical 2. Let's go ahead and rationalize that. So 5 radical 2 over 2. So let's see, so far I've got these two solutions, but I also need to check or to plug in when y is 1. Again, I need to rationalize. So then I got the solutions to be so there were 4 intersection points on this system. All right. A right triangle has an area of 84 feet squared and a hypotenuse of 25 feet long. What are the lengths of its other 2 sides? So I'm going to draw a picture first. So it has a hypotenuse of 25, and I don't know what the other 2 sides are, so I'm going to give them x and y. However, it did tell me the area is 84 feet squared, and I know the area formula is 1/2 base times height, which would be x times y in this case. So I have 1/2 xy equals 84. So there's one equation. What other equation could I write? Because I have 2 unknowns, so I need 2 equations. Let's look at the right triangle. Good, the Pythagorean theorem. So I have x squared plus y squared equals 25 squared. And then my other equation we solved was 1/2 xy equals 84. So there's your 2 equations for your system. All right, so I'm going to go ahead and solve for one of the variables. And I decided to come down here and solve for y. Again, I don't want to solve for the top one yet because I'm going to have a square root plus or minus. I'd rather wait till the end to do that. So let's see, multiplying by 2 and then dividing by x gives me 168 over x for y. So now I can go substitute that in. ahead and square this out. Alright, and this does not look very fun to work with. So I'm going to multiply both sides to get rid of the denominator by the LCD, which is x squared. Now I'm going to set it equal to 0. Let's put it in standard form as I do that. Now I need to factor it. This might take you a little bit to find. So two things that multiply together to give me 28,224, and that add to negative 625. So take a second, see if you can find those on your own, and pause me if you need to. I got negative 49 and negative 576. So when I factor that using my AC method, I got x squared minus 49 times x squared minus 576. Now I can factor that even more. And luckily it wasn't too bad. So here all my solutions for x would be plus or minus 7 and plus or minus 24. However, I know that I cannot have a negative length, so far my possibilities for x are 7 and 24. I can get rid of those negatives. So let's see what happens when x is 7. Well, y ends up being 24. And when x is 24, you probably guessed it, y ends up being 7. So the other two lengths, regardless of what order you put them in, are 24 feet and 7 feet. Okay, one more. A rectangular piece of sheet metal with an area of 1,200 inches squared is to be bent into a cylindrical length of stovepipe having a volume of 600 inches cubed. What are the dimensions of the sheet metal? Alright, so again I'm going to start with my piece of sheet metal. It tells me I have an area of 1,200, and it is rectangular, so I have a length and a width that are unknown. Then it wants me to get it into a cylinder. And it tells me that this has a volume of 600 inches cubed. So I need to write some systems of equations for this. Well, this top one's not too bad. X times y equals the 1,200. It's the bottom one that's a little bit more rough. So this guy going around right here, that's a circumference. And I know circumference is 2 pi r. However, that circumference has to be the same length as our x. So this is going to equal our x. So I could solve for r here. And I know that the radius is x divided by 2 pi. So the volume formula is pi r squared h for a cylinder. So filling in everything, I know v is 600, pi, r is x divided by 2 pi, and my height my y. So here are my two equations that I'm going to use. So I'm going to go ahead and simplify this last one we just found. Alright, so here I'm going to separate this into x times y because I know what xy equals. We found that xy equals 1200. So here 600 equals x times 1200 divided by 4 pi. Now I can solve for x. I'm going to cross multiply. So I got x to be 2 pi. So now I'm going to plug that in and solve for y. And y is 600 over pi. So the dimensions would be 2 pi inches by 600 over pi inches. That was a fun one. All right, only one more section left. You guys are doing great. I'll see you in class tomorrow.